Okay, so YouTube, we're gonna go through logarithm revision, and this we are going to revise some basic operations. So actually make sure you watch the very first video about logarithm. Make sure you understand exponents. So I'm gonna say that log and a to the power of x equals y exponents, they are very interrelated. So that's why you need to understand how exponent works before you start doing logs. Okay, so I just zoom out for you guys to go through by your own. That's 3 exercise. And so simply the questions are, from the exponent form, just write a corresponding logarithmic statement, and vice versa for logarithmic statements where you have logs. You need to be able to convert this equality or this expression into an appropriate exponential form. And you also need to be able to calculate without calculator. So actually you can use calculator, but if you're asked to do without calculator, means this question is about more like you are understanding how logs functionates. All right, so let's get to the point. Try to one more time. So try to pause the video, try to do by your own, and then try to watch my explanation. Okay, let's get started. So the first one, we have logarithmic, actually we have an exponent form, 3 to the power of 2 equals 9. And so simply we need to convert into logarithmic statement. So I show you are shown the practical way how to do that. So we consider one more time, just remind you very quick. So we consider this as the base. So the power 2 we consider as the power one more time. So that's the power, that's the base or basis, and that's the resulting value of the exponent form. So that's resulting value. Okay, so just make sure you remember how exponent works. You raise base to the power of x, you always get y. Okay, so in order to convert to logarithmic statement, you need to apply log with the base a. So So you need to apply log with the base a to both sides, and that's why we shift y here a little bit. And we also apply log a, and you also use the property that your exponent goes just in before log, and hence you'll get log a. Here is x equals to log a y. And you just remember, or you can always prove that log a is always equals to 1. So that's why when you x times 1, simply you're left with x. And that's why x equals to log a y. That's the process of converting. All right, so let's try to apply this procedure to the first 3 squared equals 9. What we're going to do, we know that in this case, the power is 2, the base is 3. So what we're going to do, we just apply log with the base of 3, and simply we have 3 squared equals log 3 of 9. Okay, so now what we can do, we simply need to put that power in before log. So we simply should multiply this 2 by the residual log 3 of 3. Log 3 of 3 is always 1, so simply just put 2 in before. So this is the shortcut actually, and 2 equals to log 3, 9. Okay, so for just some reason I want to check it first and quick, like you need to be able to check yourself whether you've done correctly. It means you need to check by doing reciprocal procedure or inverse. So inverse step. So from here, by definition, you need to be able to come back to your exponent form. All right, so let's check it here, but we'll do it quick. So log 3, 9 equals to 2. What we need to do by definition, we need to take your base, raise to the power of 2, and that's how we can get 9. All right, so let's check. 9 is 3 squared. Is it correct? Yes, it's correct. So we put a tick and say, yeah, we've done correctly. But on on the exam. So if you're really confident, don't waste your time on that. Just simply apply log to the both parts, and that's how you can get your logarithmic statement if you are asked to do so. Okay, so hope you understand how it works. I just delete that to have enough space, and right now I'm gonna do much faster. Okay, so 3 negative 3 equals 1 over 27. Okay, so let's do that. Simply we apply log to both parts. So we apply log to the left hand side. So what's the base, guys? The base is 3 because we have the bases here, or the base is 3. So that's why base of the log should be the same. Negative 3 as the power, in here will do the same. Log 3, 1 over 27. Okay, so what we're gonna do right now, log 3 over 27. Right now we just need to take that, put before, but we know that log 3 is simply 1. So that's why minus 3 times 1 is again 3. So that's why we'll get negative 3 equals to log 3, 1 over 27. That's an equivalent logarithmic statement. Okay, so what to do here? Let's do that one. We'll need to, in this case, we have 2 as the base here. So we will use log with the base 2 to the power 2.5. I just simply swap that. Swap the parts of the equation. Now it's on the left hand side. So on the right side, we'll do the same, log 2 of 4 square root of 2. So what we're going to do right now, we just simply need to say that this automatically 1 and 2.5 just goes before log. So that's what we'll get. 2.5 equals to log 2 with the base 2 of the number 4 square root of 2. Okay, so that's how it works. All right, so we have an equivalent statement. So we've done completely this one, and that one. Okay, so make sure you understand how it works. All right, so guys, check it, compare with what you've done, and we'll move next. So write in the appropriate exponential form. That's the reciprocal task, from where we need to, from logarithmic statement, we need to go back to a to the power of x equals y, which is an exponent form for your log statement. Okay, so with this is much easier, as you understand from my previous explanation. So you get 2 raised to the power of 3, and then how you can get the number inside log. So now check it. So 2 times 2 times 2 is obviously 8, so that's done. You see that for that way, actually, when from log statement we need to come back to exponent form, we'll waste much less time. All right, so let's do here. We'll need to take base of 2 raised to the power negative 1 over 2. Okay, let's do it. 2 with the power negative 1 over 2 will get 1 over square root of 2. So guys, for some student might be not obvious how from 2 to the power of negative 1 over 2 is equal to 1 over square root of 2. So why is it so? Here I'll show you, but actually for those who are pretty confident with exponents and with different notation, how to come from the surd form into the power, that's no problem. All right, I'll show you right now in a few seconds. So first of all, negative power, just remember some properties of the powers. So we'll take a to the power of negative n. We simply need to do the flip your a in the bottom part, and that's why the power becomes positive. Instead of negative n, it becomes automatically positive. So first of all, that's why I'm going to use that property, and I'll get 2 to the negative 1 over 2. I simply say that it's 2 to the form, it's 1 over 2 to the power of 1 over 2. Okay, so next step is still not that actually we desired. Right now, we are going to apply another property, what is called how to come from the nth root into the power notation. Just remember that if you take the nth root out of a, you simply get a to the power 1 over n. So many students mess up and mix up actually those two properties, and that's why they can't get it. And this only like two hard properties, I mean hard to remember, but you need to like practice a little bit and you can easily memorize that. So this is a negative power. It just simply flip over the whole, like make your number as the fraction. Okay, in this case, because it's nth root, you don't do anything with a, with under root expression, so a stays a. However, the root, nth root, becomes the fractional power 1 over n. Okay, so in this case we simply can apply that because we have 2 to the power 1 over 2. 1 over 2 means from here we can get back to the square root notation because the power 2 means square root, right? And it becomes 1 over square root of 2. Now we actually proved that the left-hand side is actually the right-hand side, okay? But, I mean, the complete answer for this in the exponent form is that one, so you don't need to prove that. I'll just simply show you why is it so, okay? I'll just simply prove that. Okay, let's move next. So make sure you guys complete 2 in the same manner, and we go to 3. Okay, what we're gonna do here, without using calculator, evaluate the following. Okay, now it's about how to calculate logs. How to calculate logs, like what's the result here? Okay, the general idea how to do that is to simply put x on the right side. Okay, so let's say it's unknown result. You don't know the result. Okay, what to do next? You just go to their exponent form. Okay, so how to go there? We're just taking 3 as the bottom part, so like as the base, and raised to the power of x by definition. So in other words, what we're gonna do, we just simply need to take your 3 as the base, and by definition of log raised to the power of x, 3 to the power of x equals to 3, your number, right? Now you're just checking. You just simply need to solve exponential equation, or equations with the exponents. So 3 to the power of x, the result is x. There are two ways. Either you're just simply writing the answer x equals 1, or you're doing like in few steps. So you're saying, okay, base is the same, the powers should be the same. However, you're thinking about power here, it's not 0, it's 1, right? So that's why the power, let me just do more precisely. Okay, so we have 3 to the power of something, and this something is actually 1. So from where x is simply 1, okay? That's how it works, guys. Okay, let's go there and let's have a solution for that. So that was solution for the first one. So let's move there. We have log 10 0.001. Let's say it's equal to x. What we're gonna do, we need to take 10 as the base, raise to the power of x, and that's how we can get 0.001. All right, right now we have like sort of different bases, 10 and something like decimal, okay? Okay, guys, what do you need to do? Just remember how you solve exponents, equation with the exponents or power equation. You just need simply say that we need to align bases. So this basis is simply 1 over, let's say 1, 2, 3, 1 over 1,000. Or you can use the index notation. So in the index notation, you simply convert 10 to the power of 3. And now you use the property just right before we discussed. A to the power of n is simply 1 over a to the power, let's say negative n, is 1 over a to the power of n. Okay, so how to apply it here? you just simply say that 10 to the power of x is 10 to the negative 3. And now it's pretty obvious because the base is the same. You just simply need to say that x is negative 3, and this is the answer. So that was the whole solution for this one. So we've done that one, we've done the first one. So here, all right, let's consider that one. Okay, so that's sort of tricky exercise. That's definitely for high tier, and we just need to consider that one. All right, so log 2 square root of 2 equals to x. What we're gonna do, we need to take 2 and raise to the power of x. That's by definition, and we'll get square root of 2. Instead of square root of 2, we'll use the formula square root nth root, of a is a to the power of 1 over n. Okay, let's apply it here so that we'll get 2 to the power of x is simply 2 to the power, it's square root. So simply we imagine that this is imaginary 2. However, mathematicians they don't use that. They just take that, and that means that it's square root of. So, however, we can convert into power notation or index notation, and simply we can say bases are aligned, so x is 1 over 2. Okay, perfect. That's the solution for that one. All right, so last two. Okay, so log 2 1 over 4 square root of 2. So again we do the same. Then we take the basis raised to the power of x, and then we get 1 over 4 square root of 2. And now we need to convert 1 over fractional number into 2 into the base of 2 with some power. Okay, how we can do that? 2 to the power of x, okay, is going to be 1 over. So instead of 4, we just use 2 squared. We use index notation one more time. So it's simply 2 squared. And instead of square root of 2, we'll use 2 to the power of 1 over 2. That's a bit more tricky, definitely. What we're going to do next, we just simply need to, because we multiplying them, just remember the property a to the power of n multiplied to the a to the power of m. What actually we need to do, we need to leave a as the basis because they are the same and add the powers. Okay, so we'll get simply 2 to the power 2 plus 1 over 2. 2 and 1 over 2. Okay, or you even say that 2 and 1 over 2 is 5 over 2 as improper fraction. So what we can say that 2 to the power of x is simply, okay, make sure you understand how I did it. I use the property when we have 2 to the bottom part and then we flipped over. So I'm talking about that property. It's here, okay? So I just move back and I simply flip it over. So from where obviously that x is negative 5 over 2. So that's why this sort of example is pretty complicated and not very obvious for lots of students. Okay, so we've done that, and let's take the last one. Okay, that was the answer for, it's a bit messy, however, for those who track that, actually you guys understand what's happening. And let's take this, the last one. So we have log 3. So we'll have log with a base of 3, 1 over 9 square root of 3. So that works in the same manner. We just mark as x, and simply what we're going to do again to take the basis, raise to the power of x, and that's how we can get 1 over 9 square root of 3. So on top of that, we can say that 3 to the power of x is simply 1 over 9 is 3 squared, and square root of 3 is 3, 1 over 2. Okay, so 3 to the power of x equals 2. Then we, using that property that allows us to combine all the powers, 3 to the power 2 and 1 over 2. 2, 1 over 2. And that's the same. So don't write it like this. It's better to write every time as an equation. So 3 to the power of x is simply 3 to the negative 2, 1 over 2. So that's why your x is negative 2, 1 over 2. Okay, so that was the basics. That was solution for, okay, it's not so like, it's not clearly seen. Okay, that was solution for that one, okay? Actually, next time I'll need to shrink the amount of numbers and problems that we're going through. Okay, so that actually how it goes. Just the last step, we just revise everything about like basics of logs, how to operate with them. Just check your solutions here, here, and actually the last one. So the whole set, that what we've done in the end. So for that we have x negative 2, 1 over 2, which is 5 over 2 as well. Okay, so guys, hope you enjoy. So next time I'll definitely shrink the amount of problems that we're going to consider in revision, or maybe just proper scale up the space. So please excuse me for that. Okay, so but anyway, so my goal was to to give you understanding how to technically works with logs, and that's what you need to apply in your exams. Hope you enjoy. Don't forget to subscribe, give some comments about whether it was useful. Maybe I need to create another videos. So I hope I help you guys, and peace.